Hello my dear students. Today we can discuss about types of hydraulic jump. So we know that hydraulic jump is defined as the rise of the water level which takes place through the transformation of the unstable shooting flow, that is a supercritical flow, to the stable streaming flow, that is a subcritical flow. So there are 5 types of hydraulic jump. First one is the angular jump, second one is the weak jump, third one is the oscillating jump, fourth one is the steady jump, and fifth one is the strong jump. So these are the types of hydraulic jump. So first one is the angular jump. In angular jump, the fruits number 1 to 1.7, fruits number is 1 to 1.7, and the water surface shows some undulations. So the water surface shows some undulations and the jump is called angular jump. So in an angular jump, the fruits number equal 1 to 1.7 and the water surface shows some undulations. So that type of jump is known as angular jump. So the figure shows an angular jump. So here the fruits number Fe equal 1 to 1.7 and the water surface shows some undulations. So the jump is called angular jump. So the second type of jump is weak jump. So in angular jump, the Fe is 1 to 1.7 and in weak jump, Fe is 1.7 to 2.5 and the jump formed is weak jump. And here the velocity throughout is fairly uniform velocity and only a small amount of energy is dissipated. Only a small amount of energy is dissipated. So a small amount of energy is dissipated in the weak jump, and in this case a series of small rollers formed on the jump surface, but the downstream water remains quite smooth. Only small rollers were formed on the surface, jump surface, but in the downstream the surface remains quite smooth. So the figure shows the weak jump. So Fe equal 1.7 to 2.5. So the velocity of the flow throughout is fairly uniform. And there are small rollers formed on the jump surface, but the downstream side remains quite smooth. So this is the figure of the weak jump. Now the third type of jump is the oscillating jump, and in oscillating jump, the fruits number equal 2.5 to 4.5, and here the entering jet of water oscillates back and forth from the bottom to the surface and back again. So the entering jet of water will oscillate back and forth, and it oscillates from the bottom to the surface and back again. So that's about the oscillating jump. So this is the figure of oscillating jump. Fe equal 2.5 to 4.5. So the entering jet of water oscillates back and forth. From the bottom of the surface. So the fourth jump is the steady jump. So for steady jump, the Fe equal 4.5 to 9. And the jump which is formed here is well stabilized and it is called steady jump. So the jump formed is well stabilized, so it is known as steady jump. So for this jump, the energy dissipation ranges from 45 to 70%. So the energy dissipation ranges from 45 to 70%. So the figure shows the steady jump whose fruits number equal 4.5 to 9. So the jump formed here is stabilized jump. So it's known as the steady jump, and the energy dissipation ranges from 45 to 70%. Small rollers are also formed on the jump. So the last jump is the strong jump. For strong jump, the Fe1 equal 9 and the larger jump formed is strong jump. Larger jump formed is called a strong jump. So here the fruits number Fe equal 9. And in this case, a rough surface prevails which continues the downstream for a long distance. So it has in this case a rough surface it prevails which continues the downstream from a long distance, and the jump action is quite rough but it's effective. So jump action is quite rough but it is effective, and the energy dissipation may reach 85% for strong jump. So the figure shows the strong jump whose fruits number equal 9. So in this case a rough surface which prevails continues downstream for a long distance, and the jump is quite rough but is effective since the energy dissipation is 85%. Fruits number equal 9. So we have discussed about the types of hydraulic jump. The various types of hydraulic jump were undulate jump, second weak jump, third one oscillating jump, fourth one steady jump, fifth one strong jump. So the undulate jump whose fruits number equal 1 to 1.7 and the surface water shows some undulations. And the jump is called undulate jump. Next is a weak jump. Fruits number ranges from 1.7 to 2.5, and here the velocity throughout is fairly uniform. Only a small amount of energy is dissipated, and in this case a series of small rollers which is the rollers which is formed on the surface, but the downstream side remains quite smooth. Next, the oscillating jump, fruits number equal 2.5 to 4.5, and here the entering jet of water oscillates back and forth from the bottom of the surface then back again. Next is the steady jump, and whose fruits number equal 4.5 to 9, and the jump which is formed is well stabilized, and energy dissipation ranges from 45 to 70%. And last one is the strong jump whose fruits number equal 9, and here the jump is quite rough but it's effective, and the energy dissipation may reach 85%. So these are the figures of the various jumps: undulate jump, weak jump, oscillating jump, steady jump and strong jump.